Welcome to Cornerstone Home Inspector Education Center. Tonight we have Chris Gould, who is a Northeast product specialist with Urel Corporation, and he'll be speaking to us about state water heaters. If you have any questions, feel free to use your chat bot, or you can break in. We do ask you to keep yourself muted at all times unless you're asking a question, and I'll hand it over to Chris.
Okay. Thank you. Appreciate you guys having me here tonight. True to the form there, I'm our Northeast product specialist for all things water heaters. Been doing this for going on 17 years for Urel, for State and A.O. Smith. So this is a presentation that's for you. It's the hot topics kind of that everyone's chatting about at the trade locations in the Northeast. And I was going to give you a little preempt into some newer product that you'll start seeing coming through, and wanted to give you kind of some indicators of what's installed correctly or not, just by vision. So without further ado, I'm going to jump right in. Again, I represent State and A.O. Smith. We cover all of New England. I'm going to go over. There we are. So we have some big dates coming up, per se. And the first one that we're all talking about right now is May of 2029, the DOE standards change. So the DOE, who runs Energy Star, basically back in 2017, put a law out that is going to change the new standards, kind of like what we used to call as NECA 4. It's going to change the regulations in regards to manufacturing this time. So with regards to that, we have a big date coming in May of 2029. And the big change there is over 35-gallon electric element water heaters will cease to be manufactured. So we have a huge change coming up here. And why it's pertinent now is our minimum threshold warranty-wise is 6 years. So we're selling water heaters today that will be well into, still have a warranty for a substantial amount of time, never mind our 8, 10, and 12-year warranty water heaters. So we're talking about that today. The other thing is what's going to replace it. So we're going to be mandated in some shape or form, whether it's a self-encompassed heat pump water heater or a split heat pump water heater, be forced to change an electric water heater to something with a heat pump. So that's rapidly coming about. The big problem with moving from electric element water heaters, and we'll talk about that more in a few minutes, going to heat pumps is we need air. So the big problem there is movement of air in cubic feet. I'll give you some segues into that in a few minutes. So big change there with residential coming. We're saving atmospheric. There was a big talk out there that atmospheric gas chimney vent water heaters would go away. We were able to keep that in play for the 29 standards by adding a backflow damper, so a draft damper into our atmospheric water heaters. Another thing I wanted to talk about briefly, I know that predominantly none of you do commercial per se. This will come up though, because the reality is the DOE standards are the same across the board, really residentially and commercially manufacturing wise, except for ASME rules. We have a big one that lands for commercial this year, October of 26, and that is us needing to cease manufacturing any non-condensing hot water heaters. So atmospheric vent, chimney vent, Berkeys, non-condensing domestic boilers are also going to be going by the wayside, that everything will have to move to condensing. And in the New England market, this is a big move. It's usually a segue to what will ebb down to the residential world. But the reality is this is about 35% of our market commercially, atmospheric. So you'll see a big change there. The distributors can sell through any of the residential changes or the commercial changes. They can sell through their inventory indefinitely. But once the product's gone, it's off the market. Couple things that, just for you to identify. One of probably the biggest things other than visual issues is identifying a water heater in its vintage. So with us, what we did a couple of years ago, we're going back 3 years, we decided to activate our QRs on our model serial tags. And our model serial tags, residential and commercial, have had QRs for 14 years. So what we did with that is activated the QR that's on the model serial tag, and you can scan it, take a picture of it, and scan it outside or scan it sight unseen to immediately find out what its vintage was, what week and what year it was made. That's going back as far as 14 years now. So anything A.O. Smith or State can be scanned that way. You can also find out exactly what it was. So say the plate is worn off, or you're not fully sure of what the size is per se and can't see it on the tag. By scanning that, you can find out what the exact unit was. Was it a gas atmospheric, power vent, power direct vent, condensing, non-condensing, what have you. You can also actually reference parts and whether it's under warranty still. So by scanning that, it'll tell you the vintage, whether it's in warranty, and that dates back as far as 14 years ago, which is predominantly the max age we really want to see a water heater still in place. So going forward, half the market you could identify by a QR code. Going to talk a little bit about heat pumps. I heard that you have New Yorkers and New Jersey. Northeast, specifically Connecticut, was kind of the pioneer of the heat pump boom, we call it. So heat pumps still to date for State and A.O. Smith are 3% of their sales. With the anticipated change in 29, our current percentage of residential electric water heaters is 33%. So we see a huge influx of heat pump sales in the very near future. There's a lot of technology that's really being ignored with regards to how they work. God forbid we install newer technology that's higher in its efficiency capacity, but without these being sized correctly, and this is something that you guys can start tuning into, undersizing heat pump water heaters will actually end up costing more money to run than an electric water heater. So I'm going to go into some of that. Sizing specifically. You also see, so self-encompassed all-in-one heat pump water heaters, you're now going to start seeing splits. So we had a huge launch 2 weeks ago. You'll start seeing them in trade publications, HGTVs, the DIY channels, and all of the trade channels. You're going to start seeing us advertising splits. So what these are basically storage tanks. They're going to go in lieu of an electric element water heater. And we're actually going to run 1/2-inch copper domestic water to circulate through a condenser outside. Kind of mind-blowing in regards to a cold market, but they've designed technology in that it'll self-circulate and not freeze. If we lost power and it were to freeze, they have basically what I kind of would call as freeze plugs, like on an engine block, that they'll pop and drain rather than split. So you're going to start seeing a lot of new technology coming out that you'll scratch your head of, how are they making water here? Some of the other things too, just to be mindful of is we have such tighter envelopes now, negative and positive air pressure wise. Everyone's, especially the HVAC world, worried about what do these things move for air? So heat pump water heaters inside a home are about the same compressor wise as a refrigerator. So when we're talking about BTUs, we're talking a lot about electric. The whole zero carbon footprint has really hit hard here in the Northeast. So we're taking out a lot of gas product and crossing it to electric. And the reality with electric is we don't size based on recovery. We size based on bulk draw. So with the huge change happening in the market, which is kind of haphazardly happening, so we're pulling gas product, propane, oil, what have you, and we're not really doing load tests on the house or sizing the house on their usage. And the reality is they're going to electric products that are much, much lower in hourly output. I'm spending a lot of time teaching the trade tech, you name it, installers, quite a bit. The mass saves, the CT energizes of what's the actual cross. And a lot of people don't know this, but a 1 kW, a standard residential water heater would typically be 4.5 kW, is 3,412 BTUs. When we start talking about a tankless water heater, really the threshold is 199,000 BTUs. So that kind of puts in perspective of an electric water heater is meant to be heated and stored for usage of bulk draw. And the other thing is these heat pumps, what are they doing? A lot of people are trying to sell them on that they dehumidify also. Well, they only dehumidify when they're running and they're recovering. So that's a conversation you have to be a little careful of omitting a dehumidifier because we put a heat pump water heater isn't going to necessarily equivalent to 30 or 50 pints a day. Could be 1 pint a day. Depends on your load. The other thing is temperature. So you're going to start seeing a lot of these heat pump water heaters, believe it or not, ducted. So our premier heat pump water heaters come with 8-inch start collars for flex duct. So we can actually duct these now to a larger open room. And in general, the rule of thumb is we need 450 cubic feet as a minimum for the water heater to be in a room by itself. So that's around a 10 by 7 by 7 foot type room that it needs to have for itself. If we don't have that much air, we have to duct it somewhere else. You're going to see the people ducting them to other rooms. You're going to start seeing them being ducted to outdoor outlets. So on the warmer days above 50 degrees, when we get a good recovery rate, you'll see these pulling intake and exhaust from outside. So if you see that, it's not wrong. It's someone, usually an engineer was actually involved. We have a fair amount of that going on. Naturally, we want to pull air from outside. You look at this example here in a garage, say down in Florida, where they put these heat pumps. It's 95 degrees and 80% relative humidity. It's going to act like a 4.5 kW element versus 70 degrees and 40% relative humidity, which is kind of most of our New England basements. It's about 2 kW. So you're talking about 6,900 BTUs, not a lot. So these are meant to be, the phrase bigger is better is very true with heat pumps, especially when it comes to efficiency. I'll skip this a little deep. This is something that I'd like you guys to start opening your eyes because 95% of our heat pump sales in New England are 50-gallon heat pumps. So, having you as an extra set of eyes, you walk into a 4-bedroom colonial with 3 full baths and they have a 50-gallon heat pump. That might have been okay if it were oil fired or natural gas or propane, but you're really pushing it in terms of a capability for a house like that. And this is one example I use that opens people's eyes is an electric water heater. You have an 80-gallon tank in front of you. People view it, and contractors do the same, as 80 gallons is 80 gallons. Well, the reality is we start drawing on that 80-gallon tank. What are we naturally doing? We're putting cold water in. So the engineering percentage rate of bulk drawn electric residential water heaters, stands true for commercial, is 70%. So an 80-gallon tank, perfectly satisfied to temp, really only has 57 gallons of usable water. And the crazy thing is in the Northeast, and I say this to the plumbing mechanical contractors, no one knows how much hot water we necessarily use in a shower here in New England. And the way that is equivalated is a warm shower in the Northeast through a 2.5 gallon shower head. Of that, you're using 1.75 gallons of hot water a minute. So that gives you kind of some quick math of, all right, if you like to take, say 2 back-to-back showers, they're 10 minutes long, 10 times 1.75, you're going to use 17.5 each shower times 2, around 35 gallons. You'd be good with an 80-gallon heat pump. I'm going to skip to the next one, is a 50. So 50, again, like I was telling you, are 95% of our sales. They're sold incorrectly. They're sold and installed correctly, to be honest with you. When we came to market 12 years ago, we were the first to market State and A.O. Smith, and we came to market with only 66 and 80-gallon tanks, knowing that bigger was better. Unfortunately, other competitors started making smaller tanks of 50, now of 40s out there. And you start looking at this math, the math is no different with any heat pump manufacturer. So say we have a 50-gallon tank. Of that, we only have 33.6 gallons of usable water. So the reality is 2 10-minute long showers, you're out of hot water. The worst part about it is that no one understands how heat pumps actually operate. And the way they operate is how we're told to make them operate. So the Department of Energy actually gives us all an algorithm of when we can turn our backup elements on and when we have to run the compressor. The reality is it's a 66% draw in the tank before we can turn the backup elements on when we're in hybrid mode. So we're running the heat pump and now the elements at 66%, we kick the backup elements on, and that's when you're not saving money. And if we do that in every shower, 2 showers, we're kicking in the duress, you're recovering on backup elements every day. And the reality is that the compressor, if we size based on bulk draw, that's only 2.23 amps. So if we recover on 2.25 amps versus elements that are 18 amps, we can theoretically get to 275% more efficient than an electric element water heater. So this is where the technology is proven. It's the problem is the sizing and the install side that people aren't saving money. And that's my biggest issue right now in the trade. Any questions yet?
No, I think the only
No?
question I have was going back, I should have asked it earlier. The getting rid of the electric water heaters over. Is that,
2029. Yeah.
that's national.
That's national. So this
So
is
2029, there'll be no more 35-gallon electric water heaters sold
35-gallon and above.
and above.
So 35, 40, 50, 66, 80s, 100s, all gone.
All gone. And it's got to be, at that point, if you want to sell a water heater, it's either going to be a storage tank or heat pump too.
Yep.
Wow.
So yep, go for it.
So Chris, those small water heaters, what, 10, 20-gallon ones that they have like at gas stations, or they'll still sell those, the small
They'll
ones.
still have those. Yep. So those are not instantaneous. They
Right.
list like they're electric instantaneous. They can only put out 2.5 gallons an hour. You turn on that little faucet, it's only a half gallon per minute, half and half water, hot water, cold water. So you'll still see those. You're going to start seeing codes change on a whole house electric tankless, which we don't sell a lot of up here. The reality is our electric tankless, to get one single shower, you need 80 operating amps. So electric tankless is realistically, it's starting to be banned state by state because it's not a diminisher or considered a high efficiency electric water heater anymore. You're still just arcing 2 wires underneath water. The heat pump technology is where the Department of Energy wants us to go.
So another question is, I know we're doing state water heaters today. If my math is correct, that's 36 months. Are the other manufacturers ready for this? I mean, if you're not in the heat pump business, what do you do?
So that has been the end all to, what was it? The third of federal appeal, which they lost about a month ago. My competitors, the other 2 big competitors, are not ready. They don't have the investment money. They haven't took this seriously, for lack of better words, to the extent that we did. So what we did is we knew, we have over 3 million square feet of manufacturing facilities down in Tennessee, and we knew we can't squeak in another heat pump line, to take over that kind of percentage increase. So we actually made a vested interest to build a new $50 million heat pump plant, and then a separate brand new high-end condensing tankless plant, which was like north of 80 million. And it took us 8 years to build. They're in Mexico. They're open and they're up and running. We can go up about 800% capacity. And we're pretty worried, and that's kind of why they appealed, is they said we're not ready. So there,
Yeah.
the very real likelihood of a shortage is actually DoD protected. So when we talk about state and A.O. Smith, they are considered a Department of Defense must have in the U.S. You have to have hot water. So they have federally built moats around it so it can't flood. It's pretty impressive when you talk about things that keep the world moving. Water heaters is one of them, along
Sure.
with some of our fitting lines, black malleable, things like that. If you shut the whole country down, you have to be able to make particular things. So,
Right. Okay.
Yep.
Yeah. Thank you.
Okay. So not to bore you with the math is real, and the moral of the story with heat pumps is bigger is better. And what a lot of the market is not doing, we never in the residential world really size the house. We're now making product, especially, and I always compare it this way: as back in the day when I would work at a supply house, do you want to go down the showroom? You're like, all right, sure, it's only brass and chrome. Nowadays we have 15 finishes in a showroom. It's the same thing with water heaters. We used to have 40 base models. We now have over 280 different residential models. So, there's niches for different situations that apply. Keeping on the heat pump side of things, some things that will definitively make them prematurely fail. So, when A.O. Smith or state is putting a product out in their R&D testing it, we have different thresholds for warranty for a very specific reason. I'll solve a myth that we all kind of wonder and think about of how do they come about with 6-year warranties, 8-year, 10-year, 12-year. The reality is the testing is done without the items that protect it. So first and foremost, there's things that protect a water heater. And why are water heaters the number one appliance that go in the house? It's a basic acid that's going through it versus a boiler system. Why do they last 30 years versus a water heater's 10 years? Well, we have a bunch of things going on. We have thermal condensing. So we're at high volume putting cold water into a hot vessel. If you did that to a hot water boiler in a house, it'd crack and leak on the floor. So we have what's called tank flex. We designed for it. On top of that, you're throwing oxygenated, a basic acid through it. So it's aggressive. Water heaters are the best business to be in the plumbing world because, yes, you need to replace them more often, up there with things like dishwashers and washing machines. With that being said, new technology, though, heat pump specific, what we preach is to run these at a higher temp. So what we're starting to preach in the residential world, especially where we have well water, we're really starting to preach to be above 138 degrees. 138 is the earmark for 99.9% of the bad things to die. So Legionellas, sulfate bacterias, things of that nature that are either annoying or could make you sick. So we're preaching higher temps nowadays, and that puts a lot more duress on the water heater, specifically under thermal expansion. Thermal expansion, then cathodic reaction. So there's a couple things with warranty that we don't mandate because of our competitive situation. So we don't mandate it that it'll avoid the warranty, but we preach putting in thermal expansion tanks simply because of the math. Here's the math I have memorized on the 50. We draw 40 degree water into a 50-gallon tank. We heat that up to 120 degrees. In that full tank, going from 40 to 120, we add 4.2 gallons of water to a tank that's filled. So you can imagine over 15,000 cycles of expansion like that. That's where you get premature failures. All right. Well systems, you'll have the age-old complaint or from a tradesman or a well guy. They'll say, well, I have a thermal expansion tank. It's a well tank. The reality is we want local thermal expansion because I don't want to push back to a well tank and make its pressures change of its cut in and cut out of its pressure switch. So we want thermal expansion really closer to. The other thing is with heat pumps, you'll see in this picture I have up here, we say run heat pumps in hybrid mode at their max temp of 150 degrees and mix down. So you'll see in that picture, you see a little silver cross, that's a mixing valve. Thing is, with the mixing valves, they have integral stops. So they're kind of like checks. So you're also, when you put a mixing valve in and don't have a thermal expansion tank on the open side on the cold, you're going to thermally expand harder on the tank. And that's where you get your bottom rim seal leaks. So when you come in and you see the leak coming out of the bottom of the water heater, that's a weld leak from thermal expansion. The other thing with thermal expansion is it's becoming more and more important without us necessarily explaining why. And if you see the picture to the right of a heat pump and kind of the skeleton of it, what we do to heat the water with the heat pump is we wrap the outside of the tank with basically a stainless steel line set. Stainless steel is used because it's got corrosive refrigerant, and it will actually expel heat to the carbon steel tank quicker than if we used K copper, say. So the problem with stainless, though, is you don't add a thermal expansion tank. You follow our preach of running at 150 degrees, so you're now up to like 5.5 gallons of water. It expands. And what we don't want is those line sets expanding, because it'll actually prematurely crack the refrigeration lines and give premature failures. So
Chris, when a plumber's installing this, sorry to interrupt you, when a plumber's installing this in real world, when we go out to a home and we see this hybrid heat pump water heater without an expansion tank, did they miss it? We should put it in our report as a defect or an upgrade?
I would not say that, but what it does is it puts your antenna up immediately, because what are you mainly doing? You're beelining it to the water heater. You're looking at visual. So any leaks, corrosion, anything like that. The next thing, though, is knowing that there wasn't the item that protected the water heater and that they're running it at a higher temp. Now we're looking for vintage, right? So if this is a 10-year water heater, what I'm going to say is you're almost guaranteeing that you're cutting it down a third of its lifespan.
Okay.
Yes. So what you're doing is you're going to kind of earmark, hey, I noticed that you're running it at a higher temp. This thing is 5 years into its 10-year warranty, and it doesn't have what is considered pretty important for all heat pump installs is a thermal expansion tank. Okay. This might be something that might be problematic sooner than later.
Okay, thank you.
Yep. The other thing is looking for service stickers. So beyond the thermal expansion tank, the second reason why a tank fails is because of cathodic reactions. So not changing the anodes in a water heater is the secondary, if not a close single first place on why tanks prematurely fail. So if you don't change the anode in the water heater and you have really cathodic water, meaning high pH, and you're running at a higher temp, you're going to chew through the anode rod, which is sacrificial. It's kind of like zincs on a boat. So you eat that rod. When it's done eating that lesser noble metal, which is aluminum, mag, or mag zinc blends, and we ship all mags to the Northeast. So mag will be more forgiving to sulfur issues. So we purposely put those in to avoid those issues, but it's less noble. So eat that anode quicker. And then when it's done eating that, it wants to eat something else. And that's the carbon steel from the cracks in the glass from too much tank flex.
So do you find, do you find public versus a private well more issues?
That's So any of you from Boston by chance on here? No?
Liz is.
So we have I call it the gift that keeps on giving, Cambridge Water. So Cambridge Public Water. So the reality behind public water authorities, and it's starting to change, is ANSI 61G does not mandate that we treat pH in public water or obviously well water, but more so in public water. So if we go to Cambridge, Mass, high-end town, they have the worst water in the Northeast. There isn't a water heater up there that lasts more than 6, 7, 8 years, ever.
Wow.
So
unless you treat it, right? I mean, unless
we treat it. So that, and I saw, I forget whose website I was looking at real quick. Water testing, it blows my mind how many people don't, that walk in and you know, hopefully maybe you guys offer it too, a quick pH test. I know my homework mission tonight's putting an acid neutralizer into my house, soda ash. I have basic water. I have the opposite in Northwest Connecticut. I have a pH of 4. Thankfully, all plastic piping, but I'll chew through a water heater in 2 years, right out the side, right through the anode and right out the side of it. So you got to look really at different, and I know regionally where has good water, bad water, even well wise. The reality is pH tests tell you a lot behind how the equipment will stand up in a house. If you have bad pH and you don't have water treatment, you're going to have some issues with every appliance in the house, all the way down to a boiler. So good sidebar, sorry. But the other reality behind our warranties, or our warranty levels, is what we do 6 to 8 to 10 is we just increase the anode size. So we actually do upgrade our water heaters, where we have competitors that don't and just have an umbrella policy because they prorate their heaters. It's kind of evil a little bit. Ours are actually upgraded anode wise. We don't want to warranty them.
Chris, I'm just gonna break in for 1 second on our viewing code. Our viewing code tonight is WH41922. That's WH41922. Thanks, Chris. Go ahead.
Yep. So this is an example, actually Logan Airport in Boston, Dunkin' Donuts. I always show this in my trainings, just as a kind of tell-all. So terrible location, gas water heater up in the drop ceiling. Second one being warranted. I get flags from our tech managers down in Tennessee. They'll say, hey, so-and-so is warrantying at such and such a property year after year or whatnot. I'll run out. So this one, point in case, had no thermal expansion. Threw a gauge on. The water pressure is hitting around 140. Sight on scene, never mind peaks, off hours or whatnot. So 140 PSI. We should be pretty much kicking the relief at that point. That was another argument as to why. But I brought a thermal expansion tank. The thing with thermal expansion tanks that should be looked into is they're never pre-charged correctly. So they come with 38 PSI of air. If you have 70 PSI in the building, you're going to push that bladder flat. It's not going to be able to react. You're going to push water against it. So you always want to charge a thermal expansion tank with no water pressure on it to the pressure of the building, whether it's 50, 60, 70, whatever it might be in the house. You want to charge it to the same water pressure. You'll see on the right, we installed the 70 PSI. Before you know it, we have 70 PSI exact on the gauge again. So no more thermal expansion. Heat pumps again. So this is, if you see a heat pump, this is the test for mine or anyone's heat pump water heater. So you see Rinnai's, Navient's, Bradford's, Rheems, A.O. Smith, State. You have a digital thermometer on you. You go in, they're all sealed systems. So the reason why we all did sealed systems is we don't want to involve a different trade. You change a water heater, it's meant for a plumber, not for an HVAC technician. The only test that we would have you do is a temperature test. So you'll see here the temperature of the room was 58 degrees, and then the exhaust is to be 8 degrees or lower. So in this instance, it went down to 39 degrees. Huge differential means that heat pump is working amazingly well because it's pulling heat out of the room. Kind of cold exhaust in my mind in the basement, obviously, but that's what comes as a byproduct with heat pumps. So that's the test. Digital thermometer on any and everyone's brand. You want to do the temp of the room, temp of the exhaust, have it be lower by 8 degrees or more. Over this. So yes, we're saying, in Connecticut, it's a battle, right? We don't need mixing valves by code. Massachusetts is a saving grace because mixing valves are code. So if we're pulling a permit or whatnot, you're supposed to have one. Everywhere else, mixing valves are still not the code per se. The other thing is checking breakers on electric water heaters. So I don't know how many of you do that, but probably about 10% of my electrical issues are undersized breakers in undersized gauge wiring, which is obviously in itself a fire hazard. So we want to check the breakers, make sure that standard residential electrics 4,500 watt are on 30 amp breakers. All heat pump water heaters are 30 amp breakers also. And we did that by default. Our competitors followed, so that if we're changing out a standard electric water heater, going to a heat pump or a split heat pump, 30 amp breakers will suffice. So we're not changing anything electrically. Recirc. So gray area where we're starting to get information from local inspector groups, building inspectors, that they're going to start enforcing the recirc codes. So there is a 75 equivalent length recirc law in play in Connecticut. It is not enforced yet. It is in play in Massachusetts. It is being enforced. Vermont, it is being enforced. New Hampshire, no. Rhode Island, no. Maine, not sure about New York. Sorry, I don't go past really the Westchester line still. So recirc, we got to watch out with heat pump water heaters, though. It'll be mandated by code. Problem with recirc is if it's not digitally controlled, it will take all of the heat out of the compressor, and you'll get complaints. And the homeowner, you'll see if they say that never turns off, that's because there's a constant load, and it's usually because of recirc. That's installed wrong. Heat pumps running too long. So common issue, people will say, in general, a heat pump water heater, we want to hear that it has run for 6 to 8 hours. If it ran for 6 to 8 hours, it recovered off the heat pump, which is 2.2 amps versus the 18 amp elements. That's a good sign, long usage. Everyone's recirc manual or heat pump manual says don't do recirc. It's not that you can't do recirc. There's just too many variables involved. Is the pipe insulated? At what GPM? We want the GPM to be 1.5. A standard 006 Taco that you'll see for recirc out there will run upwards towards 6 gallons a minute. The other thing is recirc is installed wrong in every home, temp-wise. So if your target temp to the house is 120, you go 15 degrees lower as a set point with recirc. So your recirc should be turning off at 105 degrees. Shouldn't try to go to 120 degrees. There is a pump out there. There's only one pump that can be used for recircing heat pump water heaters. Doesn't matter the brand. It's made by Grundfos, and it's called an HWR pump. If anything else is used with today, there's no other technology that can go 1.25, control at 15 degrees electronically. So this is the only pump for recirc for heat pumps. Tankless. So what we're having happen in the manufacturing world, and this is why we built a tankless plant, is we know our DOE standards for 29. We're going from non-condensing tankless to condensing only. So you will no longer see non-condensing tankless as of 29. That was also a part of that DOE manufacturing deadline. So you're going to see all things condensing. The problem with condensing tankless is a couple things. So one with tankless is longevity in the US, and it relates back to water quality. So public water, well water, we don't take care of our pH. pH is the single killer of tankless other than recirc. So two things kill a tankless, period. Nothing else. It's scale or low flow recirc. So these units, they're stupid boilers, for lack of better words, cheap boilers. They're taking huge swings of deltas on water. So unlike a boiler that has tempered deltaed water coming back into it, we're taking, and I saw temps as low as 37 degrees this winter, lowest in probably 15 years I've seen. and we're bringing it up to 120 instantly. So what happens with tankless, and when you go in to look at a tankless, you want to look for a couple things as indicators of whether or not it's been taken care of. First is the vintage. As a home inspector, I would say it is crucial to find the vintage of a tankless. And then you should, especially with a tankless, do a quick pH test. That's going to tell you what the useful life that's left on the tankless if they don't have descaling technology. So either descaled with a service record, or they have scale prevention. We have scale prevention on our newest units, because what we basically came to the conclusion of is we can't control descaling, and we're giving 15-year warranties on heat exchangers. We can't make it descale, so how do we protect it? We put the descaling technology in that does not need to be serviced. Everyone else's needs to be, so that we can basically run the full warranty. It's really in the vested interest of being a public company. So you'll look at this picture here. These are our new, what are called X3 tanklesses, specifically adapt models for State and A.O. Smith. So, one thing I neglected to tell you is State and A.O. Smith on the wholesale side. So this is not true for retail. So we do separate ourselves in regards to our product that goes through retail, being like A.O. Smith Signature through Lowe's, or any of the Reliance, Abishan, Orgel, Ace, those brands. They are a retail factory. So we do make the water heaters separately. Trade for State and A.O. Smith are made in the same factory. So for lack of better words, in trade, we print orange in the morning, green in the afternoon. We have the same part numbers. We have the same model numbers. Just one's got an orange sticker and one's got a green. Being a little more open with that, because it makes serviceability a lot easier. We have a lot of market penetration with both brands, that fixing water heaters has to happen in less than 20 hours. We know that, or it gets replaced. So a fun fact is all of our part numbers are the same brand to brand, is the other thing. But going back to tankless, vintage is hugely important. Proof of a service record is hugely important. And if you're out more than 5 years and you haven't descaled it, you're going to have some pretty serious issues. You want to look for scale prevention systems. So in this picture, you see the little black filter housing looking type thing. That's called catalyst exchange. What we do is we ionically coat mag and zinc to carry past the heat exchanger. So scale buildup is what hurts a tankless. It'll magnetically attract mag and zinc to a flame source. It builds up over time, and the problem that we end up having is what's called a heat exchanger crack, because we're not moving or transferring heat. So we're turning on, we're in high fire, but we're being thermally kind of insulated because of scale, and it'll eventually burn a hole right straight through the burner. That's where you get the notorious heat exchanger cracks, where you'll see drips coming from a tankless. Essentially, we've eliminated that. The other problem with servicing a tankless that we found out by doing our R&D research with every brand, we would descale the units. Every time you descale a unit, you lose on average 3 to 4% efficiency. So another indicator to tell if you have a tankless that's running properly as a home inspector, if it's condensing, no matter what the brand is, you want to see if the unit does or is producing condensate. So producing condensate from a tankless tells you that it's 90 plus. So that regardless of if it's condensing, whether or not it's actually condensing, running high efficiently, a quick indicator is to see if there's condensate coming out of the condensate line. If there is, that's telling you that we're burning to such an extent that the byproduct is water out of the fuel. If we don't have water coming out of the condensate line, that means our stack temp is raising because we're not transferring heat, and it's so hot in the burner that it's actually cooking off and kicking the water out the exhaust. So if you don't see condensate in a condensate loop while you're running it hard, you want to run it hard with cold water. If it doesn't condense and produce water, that's a bad sign that that water heater's on its way out, tankless wise. throwing a lot at you, but
Good information.
any questions? Sorry.
Yeah, question,
Yeah.
Chris. 'Cause I have a Navion 210. I've had it probably since 2013. I have it descaled every couple years, maybe every. What is a recommendation to have those things descaled? You know,
So
roughly
that,
per your
that's
manufacturer.
that's a great question, and here's the intelligent, logical answer. Right? How often do you use it, and at what level? And then on top of that, the big indicator is what's your hardness, what's your grains of hardness, and what's your pH. If you use it a lot, family of 3, 4, or 5, and you have high pH hardness, you're pushing towards needing to descale that at least every year and a half to 2 years.
Okay.
And then the other thing is what
And
these
most people don't. I've seen one opened up, and I saw all. I mean, it was just scaled up so bad, and I think most people don't do it.
Yeah, they don't. Well, so what's the shocker? Here's why tankless hasn't taken off, and it's starting to change. So us being, the largest in the world, we know just by manufacturing costs that the reality is 50, 75, larger than that. Power vent water heaters are going by the wayside. They're just too expensive. Our premier 75-gallon power vent water heaters are now $5,000. Our 50s are $3,500. You can buy these tanklesses here, 18 to 2 grand, with a 15-year warranty. So we know that this technology is ultimately going to take over the tank market like it has in Europe, Asia's, South America. We know it's coming, but we're preparing ourselves with product that you don't need to descale. Because no, you're right. The U.S. market has a black eye for tankless because we don't service them correctly, to be honest with you. The other thing that is an eye opener, say on, certain tankless product, the big thing you'll get for complaints is you also have a lot of pressure loss, right? So my unit is 8 PSI. The unit the gentleman just brought up is 23 PSI loss. So if you're in a house with 40 PSI, on the hot outlet side, you're getting a 20-pound loss. That's 20 PSI pressure on the hot going into the house. So the other problem with tankless is pressure loss, which is a big shock for people that move from a tank with 0 pressure loss to a tankless. It's an afterthought a lot of times.
Can you put a booster on those? Or I mean, the biggest thing in ice, like just personally going from a tank to a tankless is turning the water on, maybe brushing it. It just takes longer to get there. And some of these larger houses, correct me if I'm wrong, they're putting a couple systems in, or they're it's a, what is it, like a booster, or to get the water there quicker? What is that? If you
Well, and that's kind of that's a double-edged sword, right? So the big thing with a tankless is it's cold start. So in my mind, if you came to my house and you were saying you're going to install a tankless and you don't say you're going to use and integrate my recirc pump or put a third line to recirc anywhere, I would say that you're installing it wrong as the factory trainer. So that's the biggest problem with tankless is, yes, because you have a tankless, you're going to turn the shower on. You haven't even looked for your towel yet, never mind taking your clothes off because you've got 2 minutes, right? That's a big problem, though, because you're wasting 10 gallons of water doing that. Not to mention, because you don't have recirc, you're running hot water at 199,000 BTUs to heat up a pipe, all because you're not circulating it. So recirc is really, in terms of higher end homes that want to lower their costs, because you think about houses with a well, the number 2 user of electricity in a house on a well is the well, believe it or not. So you want to really install tankless. You want to look for that in your home inspectors. So you're not going to pick on that. It's not an incorrect install, but you can tell a high end install by someone really good if they put a digitally controlled recirc on a tankless, which I doubt probably any of you on this have you ever even seen, to be honest with you.
on a larger homes, or does that go with a smaller one? Like
even a smaller one, again, the reality is, and I teach plumbers this way, is so you can't get to the 3rd floor, right? Recirc at least the run in the basement. At least heat up the unit and heat up that first run of pipe before it goes north into the house. Or in specific states, you can use what are called bridge tees. So we use crossover tees. You'll find, and it's not legal in Massachusetts, it is in Connecticut and all the other surrounding states, just not Mass. It's considered a cross connection in Mass. It's a thermostatic tee that goes under the furthest faucet. It's called a crossover tee, and it goes on the furthest fixture in the house. And what it does is it'll bridge hot and cold. So on a time frame, we'll pull across and pull it back through the cold. And that's your recirc if you don't have a third line and it's an older colonial, kind of like New England is. So yes, you'll have tempered water in the cold side, but you're not waiting and wasting water up, while you're waiting for the unit to heat up in the piping. So recirc is really something that it needs to be installed to get tankless as a norm, because that's a creature comfort you lose when you go from a tank to a tankless, is the cold start part. Hopefully that helps.
Thank you.
Yeah. Things you'll start seeing. We're not there yet in Connecticut, but certainly I'm pushing for, because I've been on the receiving side of PVC still being used. We're very much pushing towards Polypro and Centrotherm type products. God forbid, category 5 stainless. But we use solid core PVC. We allow it. We're down to 2-inch. And you're going to start seeing vent lengths on tanklesses that are insane. I mean, our 3-inch, you can run 150 feet, 5 feet for each 90, up to 690s. 2-inch, 75 feet. So we're pushing out real far. You're going to start seeing tanklesses higher efficiency. So really what's been on the market over the last 15 years, you look at thermal efficiencies. And here's the thing with water heaters. We changed 3 years ago. You would look at Energy Star ratings, 5 years ago, and Energy Star's ratings were based solely on flue efficiency. So if you saw 92, 93, 95, that's the flue efficiency. So now the way water heaters are rated is not by EF as of 5 years ago. Now Energy Star rates them by what's called UEF. So if you see that and you've never really asked the question, it is a different rating. It's based on low water mass. Will give you a higher rating, thermal efficiency, and then how much water it can put out hourly. So UEF means uniform energy factor, and it's a basis of multiple algorithms that go into the efficiency. It's not just thermal efficiency. And you'll see higher UEFs on heat pumps. Heat pumps go as high as 2.75. They go up to right around 3 now. So you're essentially here, right? UEF of 0.95, you're putting in, and it is a direct derivative of gas. 100% gas, 95% of that you're putting into the hot water. So turn down is something you'll start seeing. Means nothing to you on the inspection side, but higher end equipment's coming into the residential world. We were predominantly in the tankless condensing world. All of us were 5-to-1. So your turn down would be 199,000 down to like 30,000 BTUs. Now this one, for instance, is 22-to-1. You can actually run hot water, sustained running flow with a tankless, our tankless at 0.26 GPM, where predominantly most of the tankless are still around 2 gallons a minute to keep it running. So you're going to see lower activation rates. It's the other problem with tankless, right? You've got 1 gallon shower heads or real low flow for washing your teeth, like you were mentioning. You're teetering on whether or not you're even firing the unit. So you'll get sporadic cold, hot kicks coming out. So lower activation with lower turn down will fix that. It's just a pretty picture. You're going to see longer recirc. You're going to see a lot more on recirc lines. Recirc is a huge initiative with public water authorities. They're pushing the state officials to change state codes. You'll see recirc becoming a mainstay that you'll soon be saying, should be installed or is installed. Gas lines. Thing with gas, so what we're preparing for with building our new tankless plant is essentially we're preparing, believe it or not, for a push back towards fuel. So for obvious reasons with what's going on with fuel initiatives and whatnot, but here in the Northeast, there's a huge electric carbon footprint push, especially with rebates. Problem is 2029, in a lot of instances, it won't be feasible to get enough hot water with the alternative products. So we're going to see tanklesses being put under stairways and people changing from electric to LP. We're preparing for that. All of our tankless models now come natural, and we give LP kits with all of them. So we'll allow you to switch. God forbid, believe it or not, I get a couple calls a week of we're switching from natural gas to LP. And yet I'll shake my head and say, that's fine. The orifice is in there. I don't ask anymore. I've been doing this too long. We have neat new technology we're bringing out of our commercial tank units, Italian Polidoro burners that we're starting to put into tankless. Tankless, you're going to really start seeing to actually run 15, 20 years without a hiccup. So you're starting to see that. This is just a picture of our scale technology. So what we did is we bought a company called Aquasana. You probably hear it on the radio or whatnot. State and A.O. Smith is actually their biggest initiative right now is water treatment. So we bought Aquasana, we bought Wellright, we bought about 10 other small manufacturing companies that have niche products. This one product called X3 was a proprietary product, a patented product that we bought because it doesn't degenerate. So you'll see a lot of scale prevention technologies starting to come out there. They're running them on boilers and they're running them on tanklesses, and they're degenerating. So it's actually a cartridge that has to be replaced. Our technology, you don't. That's, wow, spot on. So that's primarily it for me.
Sure.
I wanted to kind of in the forum, if there's any questions, anything that comes to mind, please feel free to ask me. I hope that was helpful, though.
That was extremely helpful. A couple of things. Our last viewing code is WH52628. That's WH52628. I guess we have a couple minutes left. One of the questions I had was, if I buy this product at Lowe's, it's the same thing as if I get it from my plumber or a wholesaler.
So I'm with you guys on here, I'll answer the question truthfully. So the reality is with us, that is actually different product. So in terms of State and A.O. Smith, they're made out of our Ashland City plant. So the trade is made out of our Ashland City. Our retail plant is in Knoxville. That's where A.O. Smith Signature, Reliance, Whirlpool, and about 10 other brands are all made. So it is a different manufacturing process. Okay. The reason we do that too is just to kind of protect and diversify, but obviously it's to kind of maintain the cost level that a company retail like that demands. Right. The reality is we still, on the retail side of things, you have to do warranties through the retail location, but we still have a factory warranty. Or if you bought from, say, like an Orange Box place, they actually assume the warranty of their product line, and that's why it's prorated. So there's definitely some differences there.
Like the tools, sometimes there's
So it's I know the Milwaukee guy pretty intimately, and he'd love to say it's different in different places. Unfortunately, it is not. Certain things. I worked for Anderson Windows in my early out of college years, and it is the same product, believe it or not. So some factories, you can't afford to have different manufacturing lines. You just put a different model number on it,
One quick question that I always see, and if anybody here hasn't seen it, I see it all the time, and I hear HVAC or plumbers, HVAC guys, is the intake and exhaust. Guys will either just gooseneck a little pipe off, they'll just leave, they won't take air from the outside, and some say, it rusts above the, if you open it up, there's rust in there, even with a boiler, even with a furnace, warm air furnace. What's your thoughts on it? And I see it a lot of times with tankless.
All right, so that's a great question. We could almost do a whole nother venting 101, right? Because the funny thing with venting is the code NFPA 54 actually dictates and relegates venting to all of us. So if you open any and all of our manuals, whether it's residential or commercial, it's actually the same little stick drawing of a house every time, with the variances from corners and soffits and openings. The reality behind the venting portion, it depends. For water heaters, there's a definitive science behind it. Okay. And this will make sense to you guys. So water heaters, what do? They run year round. Okay. So you've got water heaters run year round. The other one that is a killer right now is combis. So combis are giving the whole market a black eye. They run year round, but what they don't do is have adaptive gas drains. So the biggest problem with condensing in year round running with combi boilers or water heaters that are condensing is not catching the water coming in on the intake sides. So what we don't want is intake airs to pitch back to any product. We don't want water ever rolling back, because you pull water through a gas train, it leads to premature failure in the burner. On the exhaust side, on condensing, we always want it rolling back, every brand. So we want it to roll back because there's purposely a catch to catch the water out of the fuel. It's the same if it rolls back from the exhaust. It's going to go into the condensate catch, be neutralized, and then be pumped out. So the big problem with venting is going deeper. And I teach it a lot to plumbers, that, you know, the ones that want to listen and learn, God forbid, is on unbalanced venting. So the number one issue out there is, and this will make sense to you, whenever an installer goes to line up a product, they'll go to line up a tankless, a condensing boiler, a combi. They try to line up their exhaust first. What's the quickest way up and out to go with the exhaust? That's what all of them do. It's actually couldn't be any more incorrect. And that the way I kind of explain it is, if you're going to go straight up and out with your exhaust, now you're going to have to jog a joist bay or so over on the intake air side. So what you never want actually is to make the intake longer than the exhaust. The rule of thumb with condensing equipment, in any R&D or design engineer at any of these companies would say, you don't want the limitation or a higher vacuum it's sucking on oxygen, because what is it trying to perfectly blend? Gas and oxygen. So what you don't want to do is you want to see an intake go up and out, and then the exhaust actually take the jog. 99.9% of the installs, they don't do it that way. So, you know, if you ever see someone that does do an up and out on the intake, you had a really smart installer. And I can count on two hands in my entire state in Connecticut that are that savvy.
So the ones that don't go outside, that just they you know, they don't even have an intake, that's wrong.
So when you go outside, you want the intake to always 90 down. Okay. So if you're going out to pipe, you 90 down the intake, and you're going to either go straight or straight with a 45 on the exhaust, period.
I'm saying that don't even go outside. They just take the air from the basement. That's wrong.
So that's fine. No. And actually that in a lot of ways is better, because sidewall venting is the dirtiest venting possible now. Think about it. Guys mowing the lawn, it's windy. You got pollen, sprint. You've got, when you go out the sidewall, a lot more bird issues, mouse issues, spider issues, things like that. So believe it or not, I prefer, if I have a huge colonial with this wide open basement downstairs, I'd prefer you to take the air from the basement, as long as it hits National Fuel Code. So there's a rule, and it's the same for atmospheric gas as it is for a power vent water heater, power direct vent. If you pull the air from the basement, you can do that. You don't have to pipe out, but you need 50 cubic feet per 1,000 BTUs. So you go to throw a tankless in, you need like a 20 by 30 room now. When you do that calculation, 50 cubic feet per 1,000 BTUs, and you have a 200,000 BTU tankless water heater, all of them are, you need a huge basement. It's where, you know, where it changes was when you get back to tanks, they're more 65,000 BTUs. Okay, I can do that pretty easily in a basement. So intake air, if you can pull from the basement, honest to God, I have a new high-end commercial I claimed back from a commercial job. I put it in my house. You guys would giggle, be like, what in the heck? I pull air from my basement. just because I know it's cleaner and it's wide open.
So, do you guys have a requirement for, we see a lot on the new construction PEX being connected directly to the water heater, where
Yep. So
we're told it's supposed to be 18 inches of copper.
they're correct. Yes. Yep. You're supposed to run 18 inches of copper in Connecticut and actually in all states, really, are all kind of enforcing that for good reason. It's really also so that it doesn't end up getting floppy and whatnot. It's
Right.
rigid. It's a rigid takeoff where you can put a rigid valve that if you have an issue, you could do it right there. That's the main reason they put that code in play. So you had so many, you guys all have seen it, I'm sure. I get some pictures like, holy smokes, I lost count at 30 shark bites there and 5 different brands of pets going on. They're like, why is it going in a circle around the water heater? What the heck's going on there? Yeah.
Well,
sure
we're at 8 o'clock, and I want to thank you for your time tonight. This was great. I want to give a shout out to one of our members, Glenn Paldino, who forwarded us your guys' information, and
Yep.
so thank him. And
Glenn is the best warranty guy in the industry.
but I'm
Bar
trying,
none.
Glenn. Glenn's
Oh, yeah.
great. And no, again, I want to thank you again for your time and information. And we'll post a link up to your site on our website. And I really appreciate your time.
I appreciate your time too. Thanks,
Yeah,
guys.
great job, Chris. Very engaging.
Appreciate it. Have a good night. Have me on any other time.